our discussions. Uh, so in the last class we discussed the steam cycle, the Rankine cycle. We discussed thoroughly. Today we will discuss the steam properties, start with the steam properties, and eventually we will see some of the mathematical problems use those properties. Okay. uh, Probably I have already discussed what is steam, and I also discussed this TH diagram in the last class. So I'll not discuss those things. So today our main discussion will be three things. After three things discussions, we will go to the direct mathematical problems. So the first thing is that if I'm not wrong, I probably discussed there are three types of steam. Please give your role in the chat box. Everyone give your role in the chat box. Okay. Probably I have discussed there are three types of steam. Okay. One is wet steam, one is dry steam, and last but not the least is superheated steam. And sir, what is those things? The wet steam is that I give you the practical example. Suppose you take a pot and 5 kg of water. Okay, 5 kg of water. So you started heating in your oven, in your gas oven, and after some times we know that when the temperature reaches 100 degrees Celsius, the water starts to boil. Okay, so the water starts to boil. At that time, when it starts to boil, the steam starts to generate. Okay, the steam starts to generate. So that steam is known as wet steam. Why? Because you have taken 5 kg of water. Suppose after sometimes 1 kg of water has converted into steam, but still 4 kg of water is not converted into steam. That is, those 4 kg are still in the water form, not steam form. So that steam is known as wet steam because that steam may have water particle or water element. So that is wet steam. So what is dry steam? The dry steam will be if we convert the whole 5 kg of water into steam, and still that temperature of that steam is 100 degrees Celsius. That steam is dry steam because there is no water element in that dry steam. In that steam, that's why it is known as dry. And every 5 kg has converted into steam, and the temperature is 100 degrees Celsius. That is dry steam. So what is superheated steam? Now already all the water has been converted to the steam. Now if we give more heat, if we give more heat to the steam, at that time that heat, those steam will capture, absorb those heat, and increase its temperature. Okay, so basically when we give heat after dry steam, the temperature of that steam will increase. So the temperature will increase from 100 degrees Celsius to 150, 200, 250. So there is no limit. There is no limit of superheated steam temperature, but in a general purpose, the superheated temperature or superheated steam has a temperature more than 100 degrees Celsius. Okay, so these are the three forms of steam. I think you understand. Wet steam is still some portion of amount of water is left, water particle is left. Dry steam, whole steam has been converted into steam and there is no water particle, but the temperature is 100 degrees Celsius. But last but not the least, superheated steam is the temperature of that steam is above 100 degrees Celsius. Okay, so these are the three types of steam. And I think you now get it, that sir, what types of steam. Now we will discuss different types of heat. There are two types of heat. Heat is energy. There are two types of heat. For that, let me draw some diagrams uh, that will help you. Okay, let me use, there's no open, okay, let me use this space. Suppose you particularly take a point, you are taking a 0 degree Celsius ice. My students, 0 degree Celsius ice. I'm representing ice as I. Okay. When we give heat, I'm just telling you that transformation of ice, water, steam. Okay. When we finish there, you will definitely understand what is that. So we starting at 0 degree Celsius ice. If we give heat, suppose we give heat here, this 0 degree Celsius ice will first turn into 0 degree Celsius water. I think you know that. 0 degree Celsius water. So when this 0 degree Celsius is further given heated, at that time the temperature will rise. Okay, the temperature will rise. How much it will rise, sir? It will rise till its boiling point. Okay, and just like in the oven you give water, that is the normal temperature of our room temperature, 27 to 8 or 30. When you give heat, it tends to rise, and when the temperature rise stops at the boiling point. So we know that there's at a normal pressure the water has a boiling point of 100 degrees Celsius. Okay, so we do not write 100 degrees Celsius, we just write as a boiling temperature. So it becomes TB. TB means boiling temperature. TB degree Celsius water. Okay, this is not steam, water. Now if we give heat this water, after that this water, the temperature will not rise, but the water will convert to steam and become TB. The temperature will remain same, my students. TB degree Celsius steam. Okay, it will be steam. After that, if we give more heat of this steam will temperature will rise and will become superheated steam. So we write as TS. Okay, we write as TS, and it is also a steam. Okay, so here you can see that I will tell two things. First of all, there are two types of heat. One is sensible heat, one is latent heat. If you check that when we give heat from 0 degree ice to 0 degree water, there is no temperature change, my student. There is only ice to water. There is a phase, the state of the material changed. When we give heat from 0 degree Celsius water to TB degree Celsius water, you see that the temperature is changing, but there is the state of the material or things are not changing. Water remains at water, but the temperature is changed 0 to T. You take this third stage, that TB degree Celsius water becomes TB degree Celsius steam. Now the temperature are constant, but the state water transforms into steam. So this is also a heat. And finally you see that the temperature is changing, but the steam remains steam. So basically there are two types of heat. One is sensible heat. This is, oh my god, what I'm trying to write. This is S. One is sensible heat, where the temperature increases or changes, but the state is constant. The state of that is constant. Another heat is latent heat. There the temperature is constant, temperature fixed, but the state is changing. You see that from 0 degree ice to 0 degree water, here the temperature is constant, but the state is changing, so that's why it is latent heat. From 0 degree water to TB degree Celsius water, here you can see that the state water remains water, but the temperature is changing, That's why it is sensible heat. Finally, here you can see that the state is changing, but not the temperature. This is latent heat. And finally, it is sensible heat. So I think you understand there are two types of heat. One is latent heat, one is sensible heat. Okay. So that was the try. And let me get back to the slides one more time. So the discussion is given here, but still the main thing is this two line. In the sensible heat, the temperature changes, but the phase are constant, and the latent heat, the phase constant, but the temperature is changed. So there are two types of heat. And in the last class, I told you that enthalpy is the total heat. Enthalpy equals to total heat of a system. So total heat or enthalpy is always equals to the summation of sensible heat and latent heat. The enthalpy is equals to sensible heat plus latent heat, both the summation of these two. So the next point will be, we already discussed there are three types of steam. So we need to find out the equation of total enthalpy of these three steam. Of these three steam, the enthalpy of the total three steam, we need to find out the equation. So before going there are some parameters we need to know. One is dryness fraction, very important parameter. I draw the stage one more time and give you the difference between wet steam, dry steam, and superheated steam. Okay, these are the 3 points I denoted. Okay, so this is the stage, this is the water, the boiling point water. Okay, this is the boiling point water, and this is the boiling point steam, my student. This is the boiling point steam, and this is also a steam. This is superheated temperature, greater than 100 degrees Celsius. Okay, so you say that when in this point, when the water comes in this point, the water starts to boil. The water starts to boil, and the water starts to boil, and the water starts to transfer into steam. But sir, what is wet steam? I told you that the wet steam, when the water starts to become steam, but still there are maximum portion or some portion of water is left, that is wet steam. But that is generalized definition. Okay, suppose you start 5 kg, I discussed, and converted 1 steam, 1 kg steam. That is also wet steam. You started 5 kg and the steam converted into 2 kg. That is also wet steam. You started 5 kg, become 3 kg steam. That is also wet steam. So wet steam has a huge span of region. So this region is this. This region is the wet steam region. In any point, the wet steam, it is called wet steam. Any point. So to identify the wet steam, we need a particular parameter, that how much wet it is. Okay, how much steam has been generated. That term will define the different types of wet steam, because you can see that from, I just told you the 3 value, there are several values between those things. So to define that, a particular term is defined, that is dryness fraction. A particular term is defined, that is dryness fraction. That will give us, that term will give us the the quantity of wet steam, or the the characteristics of wet steam. How? So suppose it is, let me remove everything. So what is dryness fraction? The dryness fraction from, we can easily understand that it is the, it will be the ratio. And dryness fraction basically a ratio, but we will not discuss that. We will discuss in a different way. Dryness fraction. In a wet steam, we know that some portion of steam has been converted into steam, some portion of the water, not fully. So how much steam has been generated from that overall amount of wet? That is the dryness fraction. Suppose the dryness fraction is defined as x. Okay, x is given as 0.5. Suppose we are just getting from the backspace, not starting from the manually, but totally we are defining this from the result. So suppose the dryness fraction is x equals to 0.5. So what does it mean? It means that 50% of your water has converted into steam. Okay. So suppose what the meaning of 0.9? 0.9 meaning is 90 by 100. Okay, 90 by 100, that means 90% of your water has converted into steam. So this is a ratio. Is a ratio what? So what how can we represent? We represent that the upper value will be the amount of dry steam. The upper value will be the amount of steam, and the lower value will be the total water we took. The total water we took. Okay, the total water we took can be also debugged as the amount of steam generated already and amount of water left. Okay, so that is the equation here. It is written as, but we don't need to write this way. That you see that mg equals to actual weight of dry steam and weight of water in suspension. That is, that weight of water is left. Okay, but we can define it this way also. That's a dryness fraction is that particular fraction or a parameter that defines that how much steam has been generated from the overall weight of the water. Okay, so if you, I think that from now on, if you see anything that, or the dryness fraction x equals to 0.8, that means from 100%, 80% of the water has been converted to steam. So that means 20% is still left. 20% is still left in water. So that's why it is known as wet steam. Okay, so this parameter gives us the opportunity to divide different types of wet steam, because everything is known as wet steam, but this gives us more specific value that what type of wet steam it is and how much steam has been converted. So this is wet steam parameter. Okay, so let me draw one more time that this is the one more time. Okay, one more time. So this is the zone of wet steam. This is the zone of wet steam. So when the steam reaches this point we all know that this is 100 degrees Celsius steam. This point it has all steam. There is no water element available here. So this point is known as dry steam. Okay, so this point is known as dry steam because there is no water element available from here. From this point steam, if we give more heat, we get the superheated steam. We get the superheated steam. So basically dry steam has only one point, wet steam has a region, and superheated steam has also a region, but dry steam has only one point available in the water to steam transformation line. Okay. Let's go to now. We will just give a mathematical, mathematical expression of sensible heat. There are two types of heat we discussed already: sensible heat and latent heat. Okay, so we will give the explanation or the mathematical expression of those two heat. So first you think that what is sensible heat? We all know this equation: Q equals to, in our secondary or higher secondary, is ms del T. This is the calorimetry equation. Ms delta, the amount of heat available. This is the equation where M represents mass, S represents specific heat, and del T represents the change in temperature. Okay, so this is the sensible heat equation. So from here on, uh, throughout the whole mathematics, we'll use a specific given table. Here, the mass has been considered as 1 kg. The mass has been considered as 1 kg. That's why we will also take the equation as 1 kg. So if you represent m equals to 1, the specific heat of water is 4.2 kilojoule. This is a specific value, 4.2 kilojoule. The specific heat of water. So 4.2, sorry for my bad drawing. And del T, suppose if the temperature change from 0 to T degree Celsius, 0 to T degree Celsius. So the del T will be T minus 0, it will be T. So finally, the sensible heat equation will be 4.2 into T. You see, check from here, 4.2 into T. That's a 1 kg for mass. Specific heat is given here, and the that amount of change in temperature T minus 0, that is 4.2 into T kilojoule. That is the sensible heat equation we will use next. So next, so what is latent heat equation? Latent heat equation is there is nothing, just x into a particular value. Suppose x means, the dryness fraction. We already told that how much the steam has been converted. So if we have the total, if we get the total latent heat, suppose 500, total 500, suppose total latent heat is 500, and our 80% has been converted into steam. So at that time, we just multiply with 0.8 or 0.8. Sorry for my bad drawing. Yes, 0.8, we will get the is 400. Okay, so the sense latent heat we will not need because there is no amount of temperature change in this type of heat. There is a state change, so we will just calculate in this way. Okay, so next we will try to develop the total heat equation for three steam. For all three steam, we will try to develop for the wet steam, for dry steam, and the superheated steam. So let me draw the diagram one more time. Okay, the H, you see that HF, HFG, something like this. HF is represent as sensible heat. HF is represented as sensible heat, and HFG, you can take note, or it will be in the video also. HFG is represented as latent heat. Okay, so don't get confused. HF is sensible heat, HFG is latent heat. You can write in this way also. So let me draw one more time that transformation. So this was the dry steam region, dry steam point. This was the superheated steam, and this total is wet steam region. Okay, so wet steam region. So now we need to make the equation for both three. So we all know that this is sensible heat and this is latent heat. There's a change of state, not the temperature. So for to get the wet steam, we need, first of all, from this point, we need to pass the sensible heat and finally getting here. So definitely for sensible heat, the total heat will be that for the wet steam, the total heat will be the sensible heat plus the amount of latent heat. Why? Because in the wet steam, sorry, I lost the whole drawing. Okay, one by one. Suppose this is the wet steam point. Okay, so this is the dryness fraction. So to get from this point, suppose this 0 point to here, we need to add the sensible heat first till here. Then we need to add this portion. Okay, so So the equation will be something like that. For the wet steam will be, total heat is H equals to, definitely we need to calculate this one, this sensible heat. We told that it is represented at HF, plus we need to add this latent heat, as this is the wet steam. That's why a certain portion of water has been transferred into steam. That's why X into HFG, HFG. That's why it is still that H into HFG, where X is the dryness fraction, that amount of steam, 80%, 90%, 20%, 30%. That that will be given in the example. So this is for wet steam. And let's clear the drawing one more time. What is the dry steam? So the dry steam is something like that. This is the dry steam point. So this is sensible heat, this is latent heat. So we need to just add both whole sensible heat and whole latent heat. We will get the equation. So you see that H equals to HF plus HFG. So there is no critical case. For superheated steam, you see that, suppose this is superheated temperature Ts, superheated temperature Ts. So for superheated steam, you have to come till this point here, also this part. So total 3 part. Okay. So this 2 part will be the same, and 3 part will be Ms del T, sensible heat. This is sensible heat. This is not latent heat. This is sensible heat. So this is Ms del T. Okay. Ms del T. Ms del T. And I told you that in this equation, or in this further mathematical problem, the value of M will be 1, and the S will be given the specific heat, and the del T will be the change of temperature. So this point temperature, the dry steam point temperature is TB, the boiling point, and this temperature is TS. So that's why you see that the C is specific heat, C, S, everything is same. C and S is same. And the temperature change is the T sup, means superheated temperature TS minus TB. So that is the change of temperature. So for the superheated steam, this equation is look like. Okay. So now let's see one example, then it will be okay. Today we'll see only one example, but other two are given here. Let me before going there, okay, let's start this small example, then discuss one by one. Okay, suppose telling that at P equals to 10 bar, if the dryness fraction is X equals to 0.9, what will be the value of H of that steam? So in this example, at first we need to find out what type of steam they are talking about. What type of steam? Because we saw that for 3 steam the equation are different. Okay, so there is nothing written directly that it is wet steam or dry steam or superheated steam. Okay, so how can we guess? You see that we discussed dryness fraction for wet steam only. The dryness fraction is for wet steam. So though there is nothing written as wet steam in this example, but the dryness fraction value is given, that's why it is wet steam. Because for dry steam there is nothing required for dryness fraction, because we know that for the dry steam all the water has converted to the steam, so there is no portion of water left. So that's why there is no fraction remaining. So the fraction remains only in wet steam. So that's why when in example you see that the dryness fraction is given, you can definitely guess or take decision that this is for wet steam. So you see that the dryness fraction is given, and tell that what will be the value of H, the total heat or the enthalpy, okay, of that steam. So for dry steam we all know, for wet steam we all know that the heat will be HF plus X into HFG.
H into x into HFG. Here you see that the dryness fraction is given x, the value of x is given, which is 0.9. Sir, from where we will get this sensible heat and this latent heat? From where? So it's a very interesting type of example. So basically we will use a particular table where this type of value are given. Value are given against different pressure. Against different pressure, this type of value is given. So here we have the pressure of 10 bar. So the pressure of 10 bar we have given. So we'll go to the steam table. The table is something like that. You see the table. We don't need all the value, but we will need 3 to 4 columns. Here, this is the HF, the sensible heat, and this R, this is not R, this is HFG, this is latent heat. Okay, remember HF, this is sensible heat, and R is HFG, the latent heat. So from here you can see that there are so many pressure values are given here from the first column. So from 10 we'll go from 10, we'll directly go in this line. Same, we see that 7, this is our sensible heat, and this is 12.14 or 12 2015, this is our latent heat. So from using this steam table we will take those two value and go back to our mathematics one more time. So you see that at P equals to 10 bar from steam table I just showed you, the HF equals to and the HFG, the two value are given. So after that we put this all values here and we finally we get the total heat or the total heat of the system of that wet steam. So this is how we will use the steam table to find out the different types of example. Okay, so today we will not continue our next example. You check by yourself first at home, but in the next class we will discuss this to the rest of the examples, so that it gives you much more clear idea. So I am unmuting my other all students. So is there any thing you need to ask? Everyone is unmuted. Everyone is unmuted. So is there any question, my students? Students, is there any question?
No, sir.
Okay. Other students? Other students?
No, sir. No, sir. We understood.
Okay. So I give you this slide. You check the rest of the two examples by yourself. But tomorrow, no, not tomorrow. It is day after tomorrow. We'll discuss the rest of the two examples. But before, I will tell you that you check this steam table properly. Okay, because this is very interesting. This is HF, this is R, this is HFG. So it has the respective pressure, and the respective pressure value, it has the sensible heat and the latent heat given here. So we have to take value from here to solve our examples. Okay, so you check these slides properly, and coming back to the next class we will discuss from now on. So if you don't have any questions, I can end our class here. My students?
Yes, sir.
Anything else?
Okay, sir. Okay, sir.
Okay,
Thank
sir.
you.
No.
Okay. Okay, I'm giving you the class lecture as soon as I finish the class, and also the video lecture as soon as everything is settled out. Within 2 days, no problem. I will give you. So till then, take care, everyone. Stay home, stay safe, and try to study.
Okay, sir.
Okay.
Thank you very much.